So now we're going to make this a little bit more interesting, and we're going to throw in product rule and quotient rule along with our chain rule. So let's look at a few examples. And this is where we're going to really start writing out those use substitutions, because you don't always have a table to be able to do that. So let's look at that first one. We have y equals 3x times x squared plus 1 to the third power. So notice we have two functions here. 3x is one function, x squared plus 1 to the third is another function, but this guy we're going to have to use the chain rule for. So when we set up our product rule says it's the first one times the derivative of the second. So I'm doing my setup. I am not taking the derivative yet. Plus the second one times the derivative of the first. Now we're going to have to take some derivatives. So we're going to have 3x, and then we're going to have times some stuff here, plus x squared plus 1 to the third, and the derivative of 3x is 3. But what is this stuff? How do we find that? That's where the chain rule is going to come in. So I'm going to do that off to the side. So we have x squared plus 1 to the third, and we want to take the derivative of that. So there's my notation. We've got to identify u. U is our inside function. So u is x squared plus 1. du is the derivative of that, and that's going to be 2x. Then we're going to do a rewrite. We could rewrite this function as u to the third. And then if we take the derivative of that, we have 3u squared times du. And then substitute. U was x squared plus 1. Du was 2x. Clean it up. 6x times x squared plus 1 squared. So that's what's going in here. So now let's clean this up. We have 3x times 6x, which is 18x squared, times x squared plus 1 squared, plus 3 times x squared plus 1 cubed. Now, let's look at what these two terms have in common. They both have in common a 3, and they have the group x squared plus 1 squared in common. So if we factor that out, factoring out a 3 from that 18x squared is going to leave us with a 6x squared. And notice we factored all of the x squared plus 1's out. If we look at this, the only thing that's going to be left is the group x squared plus 1. Clean up your final answer. So this is 7x squared plus 1. So there's our derivative. Okay, so a couple of things I want you to get out of this. First, we can go through that same process that we did before and write out each step. Okay, so that table that we had in the previous video, we found u, we found du, we did a rewrite, then we took the derivative and we did a substitution. So it's the same thing that we did over here. U, du, rewrite, take the derivative, substitute. We are just having to write it out. Okay. Notice also I did that over to the side. And then once I found that final answer, I substituted it in where I needed to. And then we cleaned it up and we did some factoring. That factoring is going to be important. Later, we are going to be setting these derivatives equal to 0, and we're going to have it in factored form. Let's look at a quotient rule. Let's look at number 3. So we have a quotient rule here, but when I take the derivative of the top, notice I'm going to have a chain rule when I take that derivative. So let's set up our quotient rule. Quotient rule says it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So let's go through, simplify, do what we can, and then we'll do the chain rule off to the side. When you're working these types of problems, it's important to keep order to what you're doing so you know what's what in the problem. So we don't know the derivative of this piece yet, so I'm just going to leave it as parentheses. So 2x cubed times stuff minus x cubed minus 7 to the fourth. And the derivative of 2x cubed is 6x squared. And then if we look at the denominator, 2x to the third is going to be 4x to the sixth. Okay, off to the side, I need to find the derivative of x cubed minus 7 raised to the fourth power. So let's do a substitution. U is x cubed minus 7. Du is 3x squared. We're going to do our rewrite. So now we're taking the derivative of u to the fourth. And that derivative is 4u cubed times du. And then let's substitute back in. So we have 4 times u, which is x cubed minus 7, raised to the third, times du, which is 3x squared. So we're going to have 12x squared times x cubed minus 7 to the third. So that's what's going in this blank. 12x squared times x cubed minus 7 to the third. Now we have to simplify. We have 12x cubed times, 2x cubed times 12x squared. So that's 24x to the fifth times x cubed minus 7 to the third minus 6x squared times x cubed minus 7 to the fourth, all over 4x to the sixth. Let's do some factoring. If I look at the two terms in the top, we could factor out a 6x squared times x cubed minus 7 to the third. And let's see what's left. If I factor 6x squared out of this, I'm going to have 4x cubed. And notice I pulled out all of those groups of x cubed minus 7. If I look at here, I pulled out the minus 6x squared. I pulled out the 6x squared. I'm left with the minus. And I've factored out 3 groups of the x cubed minus 7. That leaves me with 1 group there. Notice I kept that in parentheses. That negative does have to distribute to everything in here. All that's over 4x to the 6th. So I have 6x squared times x cubed minus 7 to the third times 4x cubed minus x cubed is 3x cubed. Distribute, and you're going to have a plus 7 there. And then finally, we can reduce this just a little bit more. You can reduce those numbers. 2 goes into both. And we can reduce those x's. We have x to the fourth left in the bottom. And there's our final answer. Let's do a logarithm one. Let's look at number 5. We have y is equal to the log base 2 of 3x squared minus 1. So this isn't a quotient or a chain rule problem. Sorry, this isn't a quotient or product rule, but it is a chain rule. So let's think about u. In this case, u is going to be that inside function, 3x squared minus 1. du is the derivative of that, which is 6x. Now we're going to do a rewrite. So if we rewrite this function, we're going to have the log base 2 of u. The derivative of that is 1 over the ln of 2 times 1 over u times du. And we could rewrite that as du over u ln of 2. And then make our substitution. Du was 6x. U was 3x squared minus 1. So final answer is 6x over 3x squared minus 1 multiplied by the ln of 2 in the denominator. Let's look at number 7. We have y is equal to 2x over the square root of x minus 3. So this is a quotient rule. Quotient rule says it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. The derivative of 2x is 2. But we're going to have to take the derivative of this, and that's going to be a chain rule problem. So I'm just going to leave a blank here for now until we find that. Over the bottom squared, when I square a square root, I'm just going to get what's under the radical. So I'm going to get x minus 3. So now let's go off to the side. We have the square root of x minus 3 we want to take the derivative of. And we know we could rewrite square roots as a 1/2 power. So we're going to let u be that inside function, x minus 3. du is just 1. And then we're going to rewrite. It's important to remember these steps. So we're going to have u to the 1/2. Then take the derivative. We're going to have 1/2 u to the negative 1/2 times du. And then finally substitute in 1/2 x minus 3 to the negative 1/2 times du, which is 1. So that is what goes into that blank. So we're going to have 1/2 times x minus 3 to the negative 1/2. Let's do some simplifying. So this is 2 times x minus 3 to the 1/2 minus 2x times 1/2 is just going to be a minus x there. X minus 3 to the negative 1/2 over x minus 3. So we're going to factor out the x minus 3 to the negative 1/2. Notice every time we factored out, we always pulled out that smallest exponent on that group. And in this case, the smallest exponent is that negative 1/2. Now, let's think about what's left. If I pull that out of the first group, I'm going to be left with the 2 times x minus 3. Okay, if you think about redistributing, when I distribute that x minus 3 to the negative 1/2 times x minus 3 to the 1, we would add those exponents together, and that would give us that positive 1/2 back. And then we pulled all of those out of that second term. So we just have just a minus x there. So I'm going to do a couple of things in this step. This is a negative exponent. I'm going to bring it down. So now I have an x minus 3 to the 1/2 times x minus 3. And in the top, I'm going to distribute that 2x. Sorry, I'm going to distribute the 2 to get 2x minus 6. And then finally, we're just going to clean this up. This is x minus 6 all over x minus 3 to the 3/2 power. So there is our derivative.